Hi class. In this video, I'm going to be talking about digital imaging. This is our first topic of the semester, and we're going to be using a couple different Adobe software products, Photoshop and Illustrator, to create some digital images. So we're going to learn about the process of image creation, how to publish an image and create different formats for the web and other contexts. And we'll go over adding filters, compositing images, a bunch of other topics. In this video, I'm just going to go over some of the basics, some of the terms. So this is more of a lecture where I'm just going to be talking about some of the concepts. You can see I have Photoshop open. So you're probably not going to be super familiar with Photoshop yet at this point, but that's okay. In the next video, I'm going to go over some of the basics, and we're going to do a quick demo on creating a image composite. For now, I'm just using it to kind of demonstrate some of the technology and also just create a little slideshow to go through some of the basics. And so that's what we're going to be doing in this video. There are a lot of very important concepts in here, so it's going to make it a lot easier to understand what you're going to be looking at in the next video when we actually start to get into some hands-on work with Photoshop. I'll just get started. And so I'm going to use Photoshop as my tool here. I'm going to go into a separate view to kind of make it a little bit bigger, but I'm going to be moving into another view to change the slides. And so this is digital imaging, and this is our first lecture of the semester, and this is going to be the first topic that we are working on this semester. And so to get started talking about digital imaging, we're going to talk about pixels. And pixels are sort of the basic unit of any image. And we'll look at that in a lot of detail when we actually create some images in Photoshop. Here you can see a couple images. The one on the left of the lizard just looks like a regular photograph. There's a lot of detail, different colors, and it just kind of looks like, you know, an image. On the right, what we see is a very zoomed in, cropped part of this image. And what we start to see is the squares, the individual pixels that make up this image. So since we're in Photoshop, let's actually just zoom in here. So you can see as I zoom into this lizard, eventually what we're going to see are just these boxes of color. And so each one of these boxes is assigned a different color, and the computer or the camera or the editor or the designer, you know, we make choices about what these colors will look like and how they fit together. And eventually when we zoom all the way out, we get a digital image, which just looks like, you know, a photograph that we would see anywhere. And so the pixels are what makes up the screen on the computer or any device that you use. And they're basically just an array of really tiny lights. And we use those lights to create color, and then we put those colors together to create an image. So let's keep going. So pixels are made out of red, green, and blue lights. And so RGB is a term that you're going to hear a lot. You've probably maybe heard it before. But it stands for red, green, blue, and that's basically how all of our devices work. They use red, green, and blue lights, and they mix them together in different amounts to create different colors. And so in each one of our pixels, we have assigned a color, and that color, it actually has 4 values, but we're just looking at the 3 color values right now. There's an amount of red, an amount of green, and an amount of blue. And in the digital color space, we can mix these colors together as at different amounts to get millions of different colors. And so we have 3 channels, red, green, and blue, and each channel or value is going to be in a range between 0 and 255. 0 being no light or no color, and 255 being full light or full color. And while we're in Photoshop, we can take a look at what these colors look like. So I'm going to use my color picker tool. So I'm just going to click on this color picker right here. And then what I can do is I can actually use the eyedropper to pick a color. And then what we can see there are the values that make up the color. So there's a few different things here. So there's different ways of thinking about color. And Photoshop can, represent all of those different ways. But what we're using is this RGB right here. So we can actually just click on the R and we can see we've got full R. If we click on the G, we see that we don't have any G, there's no green, and then there's B, we have 0 B. So that's our color there. Let's pick our green color. So there we see green. And if I wanted to change that color, I could select different colors. So the color picker sort of like lets me see all the different colors. I can change the hue by using the slider here. And then once I'm inside the hue I want, I can make it lighter, going all the way to white, or darker all the way to black. And then I can add more color. So over here I have gray, so it's in between white and black, but there's no color. And then as I move to the right, we're adding more of that color. So we're saturating the color more. And so that's how we can kind of create colors here. Here's a few basic colors. We've got our red, which is 255 red, 0 green, 0 blue. We've got our green down here. Same thing, except we have 255 of the green. And then we have our blue with 0 red, 0 green, 255. And then a white color is going to be full on each light. So when we add all of the lights together, we get white. And then, of course, black is when there's no light at all. So each one of those channels is set to 0. So let's continue. So each color is saved using computer memory. And the amount of data that we can save is based on something called bit depth. And this might be a little confusing if you've never learned about data before. We don't really need to know a ton about this because it's not going to affect our day-to-day use of Photoshop, but it's an interesting thing to cover. So a bit is the smallest amount of information that we can save on a computer, and it stands for binary digit. And so it's basically just a little box, and it can either be a 0 or a 1. And so we see those bits over there on the left. And a byte is essentially 8 bits put together. And a byte is sort of an efficient amount of information, and we can represent different values with a byte. And the way that works is that we have 8 different values, and they can either be 0 or they can be 1. That's all. But the position of each of these values represents a different number. So this first position here represents 1. And so if that's 0, that this is 0. If it's 1, it's 1. The next box represents 2. And so if we have 1, 1, that would be 3. If we have 0, 1, that would be 2. And if we have 0, 0, of course, that would be 0, or 1, and 0 would be 1. So we can represent all those numbers with just those 2 different values. And then we're going to get more complex. We have 1, 2, the next box is 4. And you might think we skipped, but remember we can get 3 by adding 1 and 2. So now we can get 4, and we can get 4 plus 2 plus 1, so that's 7, and we can get all the numbers in between. And then we keep just going up like that. So we have 1, 2, 4, then we go to 8, then we go to 16. So you'll notice that it doubles each time. This is called powers of 2. And then we go to 32, we go to 64, and this last box on the end is 128. And so by adding those numbers together in different combinations, we can get any value between 0 and 255. And that's why red, green, and blue are going to be either 0 or 255 or somewhere in between. So for example, here we have every bit in our byte is 0, so we get 0 here. In this byte down here, every single bit is 1, and so that adds up to 255. Down here, we have something else. We have the value 100. And so let's see how we get there. So we have 1 is 0, so that's 0. 2 is 0, that's also 0. 4 is our first 1, so that's 4. Then 8 is 0. 16 is 0. 32 is 0. 32 is 1, so we get 32 there. 64 is 1, so we get 64 there. And then 128 is 0. So then we add up these numbers. So 64 plus 32, let's do that real quick. 64 plus 32, that's going to give us 4 plus 2 is 6. 6 plus 3 is, I wrote the wrong one there. 64 plus 32, 2 plus 4 is 6. 6 plus 3 is 9, that gives us 96. Whoops, we lost this. This is 4, remember? So then we get plus 4, and that's how we get to our 100. So again, we don't we're not going to be really thinking about this all the time, but I think it's just worth giving a little bit of explanation of why we see certain numbers when we're doing digital imaging. Okay, let's keep going. Okay, so the way that digital cameras create digital images and the way that we create digital images from the real world is what we do is we convert analog data. Analog data is something that's captured on a physical medium, so something like a tape or a record or film. So film is an analog media. It exposes a medium to light, and that creates sort of a sort of infinite amount of data. But we don't have the ability to save that on a computer because we really only have these bits that we saw in our previous slide. We only have zeros or ones. And so what we do is we use two processes. One is called sampling, and the other is called quantization. And both of these are very important ideas when it comes to saving digital information, whether it's images or audio or video or any other type of media. So in here, what we can see is we have our analog signal represented by the sort of blue-purple line. And sampling is basically going along that analog signal. So you could imagine, maybe it's a blue river and we're tracing along the side of the river. And there's an infinite amount of data that we could save from that river, but we can't save an infinite amount of data on our computer. So we have to pick certain points. And the goal here is to pick enough points that we can see what the river looks like, but not so many that we overload our computer and our hard drive with information. So we see the analog signal is that purple line, and then the little pink lines represent samples. So at various points along the line, we say we want to save this data, and this data, and this data, and we usually choose a regular interval to make it easier for the computer to know where to save, and then we put that onto a hard drive or a CD or some other type of digital media. So at each one of those samples, we take what's called a single sample here, and this is called quantization. And basically we have our RGB, and we actually also sometimes we have an alpha channel, which is transparency. So usually we have about this much information, which is 4 bytes worth of information. And so we have a bunch of zeros and ones that represent that much data. And the more data we use, we don't have to use we can use just a 0 or 1. It could be just black or white. But usually we want to use more data so we can capture more colors. The more data we have, the more different types of colors we can capture, and the better the image can look if we are trying to save a lot of colors. So another factor that we're going to look at is the image size. And this is just the number of pixels that make up an image. And images on computers are always square. So we always have a certain number of pixels in the width or the horizontal dimension, or sometimes we call them columns. And then we have a number of pixels for the height or the rows or the vertical dimension. The image actually doesn't have to be a square. It can be a rectangle, but it has to be a rectangle or a square, essentially. So there doesn't have to be, in this case, we have an image that's a square. It's 200 pixels by 200 pixels, but we could have an image that's 200 pixels by 50 pixels if we wanted to, or we could have an image that is taller than it is wide. We could have something that's 200 pixels by 10 pixels. But we have to have basically a width and a height. We can't have like a circle or a triangle or something like that. So along with our image size, we have something called resolution. And resolution refers to the number of pixels in physical space on a screen, or when you print something on a piece of paper that's printed. And so this is referred to as the dots per inch, or DPI. And different devices and different printers, different things, they have a different number of these pixels that they can put on the screen within a certain space. So for example, the original iPhone was very small. It had 320 pixels in width and 480 pixels in height. And the screen itself was 3.5 inches diagonally. And we'll see what that looks like on the next slide. And so there were 163 pixels per inch of space. The new iPhone 14 is 1,170 pixels wide and 2,532 pixels tall, but the screen is 6.1 inches. So the screen hasn't quite doubled, it's a little less than double, but the number of pixels per inch has almost tripled. It's much more. So we have a lot more pixels and a little bit more screen space, and so what we get is a higher definition image with more pixels, more data, and so we can represent more detail, we can create clearer images, and we have a higher resolution or higher definition. So here's our iPhones sitting next to each other. This is not to scale, but this just gives us a little bit of a sense. So we went from 320 pixels wide to 1,170 pixels wide from iPhone 1 to iPhone 14. And then the height went from 480 pixels to 2,532 pixels. And then our screen got bigger, but not quite double. It went from 3.5 inches diagonally to 6.1 inches diagonally. And so that has to do with hardware getting better, better design techniques. There's lots of things that have changed between the iPhone 1 in 2007 and the more recent iPhones in the more recent years. A lot has changed in terms of the speed of the hard drive, the speed of the processor, the size of the components, all these different things that allow us to make, to add more data, to have higher resolution images and videos and things like that. Okay, so when we're working with digital images, we have two different ways of rendering graphics. And what rendering means is really just like drawing the pixels on the screen. And so actually I'm going to go back into my Photoshop mode for a second here. And I'm going to actually click on some of these layers. So this is something that we're going to learn in a second. So here we have a raster image at the top. And what I did is I just took this text and I rasterized it. So that means I turned it into pixels. And that basically means that there is a pixel, like what we saw with our lizard image, for every single part of the image. And what that means in terms of the visual is you'll notice if I try to transform this, so I'm going to transform my raster image, and I'm going to make it a lot bigger. I'm going to scale it up by 10. So I'm going to do 1000% on the scale. And so notice, I'm going to zoom in a little bit here. And what we'll notice is that we see these little blocks. We see these edges of pixels. So when we scale up, we kind of lose that sharp edge that we had when the text was to scale. I'm going to undo that real quick. Now, let's take a look at our vector. So I'm going to zoom in here and just zoom in a little bit. So when I click on my vector, notice what happens. I get these little blue dots. And if I zoom in, I still see the same pixelation because that's how Photoshop renders our image. But look at the blue line. Notice that that's very smooth. No matter how close I get to, no matter how much I zoom in, no matter how large I make this text, that blue line stays nice and smooth and those dots stay in the same place. That's how vector graphics work. Instead of describing every single little pixel in the image, they describe a few points and then they draw color in between those points. And so the advantage here is, if you notice, if I transform my vector graphic, so I'm going to do the same thing. I'm going to increase the scale by 10. Notice that my lines stay nice and crisp. So unlike my raster that becomes pixelated, my lines, I can make this as big as I want, and those lines are going to stay nice and smooth and round and crisp. So vector is, using a different system, which it allows it to stay like that. And there's advantages to both systems. So we'll talk about that next. Though I have to get my layers back. Go to slide 12. Okay, so with raster, as we mentioned, we have a grid of pixels. This kind of looks like the lizard image that we saw in the first couple of slides. When we resize, we change the image quality, so it becomes either more pixelated or we lose some of the data if we make it bigger or smaller. Typically, raster is used for digital photographs. Digital photographs have a high degree of detail, and so it's easier to represent all of those details with individual pixels than it would be to use a vector for every single one. Photoshop is primarily a raster editor. You did see that we could do vector, and with certain things we'll start with a vector. But most of the time we're in Photoshop, we're going to be doing raster images. And raster is sort of what is mostly used for graphics when we're sharing graphics. So there's a lot of different image formats that can be saved as raster images. And we'll go over a lot of these as we do more demos with Photoshop. You've probably heard of some of these. JPEG is Joint Photographics Experts Group. This is a very well-known and highly used image format. PNG is Portable Network Graphics. This was a little bit more of a modern format that was developed specifically for the internet and for sharing images on the web. GIF is another format that was made to work with the web to make images smaller. That's the graphics interchange format, and it's become sort of colloquially associated with animated GIFs and memes that are shared online. And then PSD is the Photoshop document. That's what I'm working in now, and we'll kind of go over how that works in our next video. With vector graphics, we have coordinates. Those are those little blue dots which tell us where to start our graphics. And then we have color data, how much color or what color to put in between the dots. When we resize vector, we don't lose quality because we're just moving those dots into a different place, so we can size it up or down and get the exact same look. Typically, we're using vector for logo design, for illustration, for things that have a high level of sort of crisp cleanness, but are very simple. And we'll see lots of examples of that as we use the software. Illustrator is the software that is primarily used for vector editing, and we'll use that not this week, but probably next week. And vector is a little bit more limited in terms of the image formats that are supported. AI is going to be our Adobe Illustrator file, and then SVG, or Scalable Vector Graphics, is a web-based vector system that you can save your graphics as. We probably won't do that in this class, but it's good to know that it's available. So just an image example of a raster, typically some image with lots of detail, lots of different colors. So you can see, if we only had a couple colors or a couple dots with our lizard, we'd lose a lot of the detail there. Versus a vector, very good example is the Apple logo, very simple, basic contours, but we want to be able to, put it in lots of different contexts. We're going to make it bigger and smaller. It's going to appear in a lot of different places. So we'll go over this a lot in our next video, but as we start to work with images, we want to think about the two different types of files that we're going to be working with: edit and export files. So edit files, these are files that we use to create images in programs like Photoshop or Illustrator. These edit files save our history of edits. We have different layers. We have lots of different things that we can do with them. And they typically are very large files because we've got lots of stuff going on in them. Export files are smaller files where we simplify and kind of compress everything that we've created when we're making the image into one final product that we can then share on the web or share on different devices. And that's something that we'll go over a lot as we create projects in our demos. Another thing that we're going to talk about a bit today is the idea of copyright. We're going to be using images that we find on the web. So we're not going to be necessarily starting from scratch. We're going to find source images. And when we do that, we have to be very careful to use images that we're allowed to use. So copyright is the legal term that determines who owns something like an image or a piece of media or a piece of text. And copyright determines who's allowed to distribute, to display, to copy, or to use an image. Fortunately for us, there are a lot of resources that are either public domain or Creative Commons. These are both copyright licenses that say, you can use this image and you can, as long as you follow certain rules, you don't have to buy it. You don't have to pay me. I can't sue you if you make a project with my image. So we'll look at a few of those examples, and I'll talk about that more as we create a project. When we use images and we want to cite the author or creator of the image, we use a very specific format. And this is something, you don't need to write this down because I have a template for you to use later once we get a couple more into a couple demos and we actually start posting some stuff, we'll use this. And so don't worry about this right now, but this is just an example of how you would cite an image that you used from a website or by another creator. And this is very similar to citing sources if you're writing a paper. Okay, so that is it for our intro to digital imaging. In the next video, I'm going to do a Photoshop demo, and we're going to do something very simple just to get started. And then there's going to be another video after that, which will be just going over the process of creating your first blog post. So those are important. Those, that will help you kind of get your first project started. So that's it for this video, and I'll see you guys in the next video.